Okay, students, this is lesson number 17, and the learning target for this lesson is let's graph logarithmic functions, and also I can interpret logarithmic function in different contexts. So we're going to check how log is being used in real lives. So we will take straight away, I'll go to practice problem number 170 lesson. Here it is the first problem. So you can pause this video for a while and see if you can figure out which are the correct options for this. Okay, so in this example, a relation between bacteria population P in 1000 is given and time D is given. So this is a relationship. It does not tell you which is the input and which is the output. But then uh, since it was measured to be 1000, so in the beginning there was 1000 can be represented by equation D. So there is a relationship days, how many days passed, and it is given with the help of logarithm to the base of the population. Now what that means is, in this example, the input, see this input is the population and the output is the days. So we want to know how many days passed have passed if the population is whatever the population will be given to you. Now remember, this can be also written as in the. I want you to write this in a hard copy so that you really understand changing from. So this is also as good as writing the base is 2. So this is the base. So I'm going to use, and the P which is right here. I'm going to use red color. Okay, P is the base is 2 D. So this also is correct. So this graph, this graph is exponential, it goes something like this, and this part is the logarithm which goes this way. So they are inverse, both represent the same thing. Now in this case, where is that one? So there is a one time, so it is like in the beginning there was 1000. This means 1000 population. This is days past. Since in the beginning how much it was. So it's like if you see it this way, the first one is the population, and if this is the day, in the beginning it was 1000. So instead of 1000, they just put 1. 1 means 1000, and so on like that. But the other one is going backwards. It means if it is 1, so if this is P, and what is this D? This P is 2 raised to D, and this D here, because you are swapping this input output, is logarithm of to the base of P. So if it is 1000, so what was the beginning? Then if it is 2000, 3000, and 4000. Now let's see which one is the correct. Each day the bacteria population grows by a scale factor of 2. Yes. See, this is the one which is correct. So this is this population, and because there is a 2, this 2 which is you see is right here. So it's growing by a factor of 2. That's the factor. Then what about the second question? This also defines the relation, and there you go. I already shown you. The population reaches 7,000 after after t days. If you see the C, they said this part, log of 7,000 days. When you talk about log, see this part, this log, it's the total. It has to be number of days. Let's see this part. If you see, if I try to put this in the expression, let's see why this is wrong. This is correct. Well, let's see why this is wrong. So our log of 7,000. So the population is this. So he's saying 7,000. The population is, and this is 2 raised to uh, this part. There's a watch this part. It says reaches 7,000. Actually, should have been 7. So because this is in thousands is already said, so you cannot write this number 1000. You just say 7. Reaches 7 in those many days. So you can't have this answer. So this is wrong. Then this expression log tells us that when the population reaches 10,000. So let's see whether this is correct. So log of 10 to the base 2, and log of, and the answer is given is, so when you write this, basically it means that the population, what does log basically means? This 10 represents the population, right? So 10 means 10,000, right? 10 means 10,000. So this is correct. So this is log of 10 to the base 2. Basically, this means it is the number of days. So this basically is number of days to reach 10,000. So this expression tells us when. So the when means number of days. So when the days, how many days it required to reach 10,000. So this is correct. And finally, we have two more. This expression represents logarithmic function, and there you go, is correct, right? So this is logarithmic, that's correct. This function tells us the population reaches 128,000 in 7 years. So if you see this, so what is the meaning of this mean? Basically, logarithm, this itself means the input is 128, which basically means 128,000. So the question is, this number is the output, which is the D, this is the days. So it takes 7 days, to reach the population to reach 128,000. So that's correct. So you have this 1, 2, D, E, and F. So only wrong answer is this one. Hope that helps. So this is the second question, and you can see there's a graph here. Now, nothing is being told about what is graph means, but at least we know that, see, for this input on the x-axis, and the output is, we can pick one point. Look at this one point, and that is 1,000 is 3, right? So that means 1,000 is 3. It means I can use logarithm of 1,000 to the base 3. And the answer is how many? So this should be this should be 10, because because 1,000 is 3, for the input 1,000, the output is 3, and you can see this 10 raised to 3 is 1,000, correct? So that makes sense. And that's why, because this point was this way, we can think of logarithm graph goes this way. That's the log one. When you say logarithm, sometimes we write logarithm 10 is same as writing log of that. So without even writing the 10, it's the same thing. So on the calculator, you will see this part. So this graph here is a graph of log, but they didn't say it is logarithm. So I have to write logarithm. And the input here is, again, I repeat, this is 1,000, that goes here. The base that is used, answer is 3, but then you have to see what is this, right? So what is this number? Multiply itself 3 times. So you multiply itself 3 times to give you that 1,000. And you can clearly see it has to be 10, 10, 10. So this answer is 10. That's it. That's the reason. Okay, let's go to the next. Okay, I want you to focus in this question number 3. This is question number 3. Look at the right side first. Now, what is this? ln means it is logarithm to the base 10x. Okay. So now you're given 4 logs here. So just remember, when it is exponential, and so ln is e, sorry, this is e, which is ln of logarithm to the base of 2.7182. That's what it means. When you graph exponential function, let's see this one. So first of all, e raised to 2x. So there is a 2 here base, there is a 10, there is a 5, and there is a e right here, right? There is a e of x here. So the graph of 2, this will be like a graph of 2 raised to x. Okay. Then the next one bigger number that you see is 2.71 and this graph maybe is almost closer like this. This is e raised to x. Then I'm gonna use not red, blue to show if it is 5 raised to x. So if it is 5 raised to x, something like this, this will be a 5 raised to x, 5 raised to x. And then finally there's a 10, and the 10 is quite a big number, so I'm going to use different color. So something like this. So this is 10 raised to x. Now when you try to take the logarithm, what it does is you're going to you have to reflect this. All these three, four graphs, they will get reflected. So the higher can you see this part, when it reflects, it goes this way, something like this. See? So this will be logarithm of x, sorry, 10 to the base x. The blue color will be little above, so this will be the blue color. This is going to be blue color, which is this blue color will be log to the base. So this is log to the base 5 of x. Then the black color e raised to x. So see the b, this is e raised to x, right? So this will go here, it will go this way. So that's log to the base ex, and finally the red color 2, this 2 goes this way. So this is the understanding of. In other words, what does the log does is the higher the base you see, this 10 pink color that you see here, this pink color has the higher base 10, and when it is 10, so it is like it compresses towards the x-axis, right? Then comes the 5, then comes the e, which is 2.718, and then comes 2. So that's all you're supposed to remember. So simple. So logarithm basically is a reflection over the line y equals x of the exponential function. See, this 10 raised to x is goes, of course, it has to be below. So there is this x-axis. So this is 10 raised to x, so it goes 10 raised to x. It goes this side, and then the blue color, and you can clearly see which one. So you have to decide now which one is what. Now I want you to figure out yourself, but make sure on your paper you write this whole thing to understand the whole concept of exponential and a logarithm, how they reflect over the black dotted line. See this black dotted line? And so this is the main dotted line to reflect, and you know how the graph looks like. So the higher the base of log, it compresses more. That's all you remember. And they all go through. So the good point thing is they all go through 1, 0. What is that means? What this means, logarithm, if there is a 1 of any base, let's say if it is 1, is 0. Logarithm of 1, if it is 3, it is 0. So no matter what that base is, because 2 raised to 0 is 1. This because 3 raised to 0 is 1. That's why always that works. And one more thing you have to also remember, if it is logarithm of 3 to the base 3, it is 1. Because 3 is 3 raised to 1. In other words, you always remember that logarithm of b to the base b is 1. Hope this helps. Let's go to the next question. Okay, read the question. The graph represents the cost of medical treatment in dollars as a function of time, d in decades since 1978. That means this point is 1978, and this point is 1988. This point is 1999. Okay, and the next one is, so if you add another 10 there, so if you add 10, this becomes 900 2009. Now the question is asked, this expression represents the cost of the medical treatment sometime after 1978, which I showed. This is 0 mean 1970. Which year does it represent? So what do you think is this point? Now this point has a 0.5. That means it's 5 out of 10. That means 1 decade is 10 years. But there's the 5 years past from 0 years. So 5 years. So these are the 5 years has to be added to 1978. And if you add 5, you get 319191983. So in this expression, they gave us, see this part, they already gave us this part. Let me go back to this here. Uh, this expression represents what? Remember, in the beginning it was 150. That's 150 right here. See this 150? And then we need to know what is this point, right? And you can clearly see 0.5. That's like half a decade, right? Half a decade. So what is the meaning of half a decade? Means you add 5 years. So if we add, it should have been 1983. But if you see, there's a mistake here. It doesn't show there. So the answer is here is now 1983. So do take care of that. So there is a little mistake there. So you can always rectify it. Now for the question number, I did till 4. I want you to try question number 5. So this is just a repeat of all those. See, this is lesson number 5. The next one is lesson number 13, lesson number 14, which we already done. So I want you to try yourself as a little kind of a quiz to check on your understanding of how to go about this and get your answer. So you'll get very, very good points if you do it on your own. Remember, this is one thing I want to make sure you let's see if I can do this. Remember the question number 6. Just make sure when you have a base here, something here, it has to be same thing this side. That's all you're trying to save. The moment you have the same bases, then you can see the exponents are okay, correct, and you solve for them and you get the answer. So 6 is easy. If you each one of them you can try to put that way and get it done. Okay.